Chapter 32 पेपर क्रोमेटोग्राफी एंड थिन लेयर क्रोमेटोग्राफी। तो आज हम लोग समझेंगे पेपर क्रोमेटोग्राफी क्या होता है और इसके यूज़ क्या क्या हैं। चलिए शुरू करते हैं। पेपर क्रोमेटोग्राफी ऑफ एमिनो एसिड्स मिक्सचर। इन बायोलॉजी एंड केमिस्ट्री इट इज़ फ्रीक्वेंटली necessary to separate components of a mixture which are very similar and are difficult to separate with conventional chemical or physical methods. Chromatography and electrophoresis are two powerful modern methods which can be utilized for such work. The Russian biologist Sweet was the first to appreciate the possibilities of chromatography as early as 1906, and he coined the term chromatography in 1944. Constant, Jordan and Martin described paper chromatography in which separations are achieved mainly by partition principle. The separation of component in the paper chromatographic system depends on multiple partition processes. Small differences in the partitioning of each component of a mixture are multiplied many folds. The greater such difference or greater this multiplication factor, greater is the ease of separation. A small drop of solution containing the mixture of compounds desired to be separated is put on a strip of filter paper and allowed to dry. A suitable solvent mixture of two solvents are allowed to flow along the filter paper over this spot. Depending upon the solubility of the components of the mixture to be separated in the solvent mixture, the substances in the initial spot are extracted by the flowing solvent and carried forward along the filter paper to a distance which appears related to their partition coefficient between free and bound solvent phases of the filter paper. After the solvent has run for a suitable distance along the paper is removed, dried and subjected to suitable tests to locate the various compounds. RF value is defined as the ratio of the distance any compound moves along the paper to the distance covered by the solvent. Thus, if the solvent has moved 14 cm and the compound has moved 9.8 cm, the RF value of the compound is 9.8 upon 14, 0.7. RF for any compounds is dependent upon such factor as the nature of the solvent, the temperature and the presence of other substances. However, under a given set of conditions, the RF value of any substance is found to be reproducible and is characteristic of the substance. Reagents and chemicals. N-butanol chromatographic grade, दूसरा ग्लाइसिल एसिटिक एसिड, तीसरा सॉल्वेंट मिक्सचर ऑफ ब्यूटानॉल एसिटिक एसिड एंड डिस्टिल वाटर इन द proportion of 12:3:5. Ninhydrin 0.2% solution of ninhydrin in acetone. It is prepared just before use. Procedure. Whatman filter paper chromatographic grade is cut into 35 into 15 cm sheet. A pencil Whatman filter paper chromatographic grade is cut into 35 into 15 cm sheet. ओके, प्रोसीजर देखते हैं। Whatman filter paper chromatographic grade is cut into 35 into 15 cm sheet. A pencil line is drawn about 3 cm above the shorter edge of the paper and 5 points are marked on the line at equal spacing, leaving 2.5 cm from the two edge. On the middle point, a mixture of 4 amino acids is applied with the help of a fine capillary. It is dried with the help of hot air oven by a hair dryer. Again, another small quantity of the mixture is spotted at the same place and dried. This process is repeated 2 to 3 times more. Okay, once again, Wattman filter paper chromatographic grade is cut into 35 into 15 centimeter sheet. A pencil line is drawn about 3 centimeter above the shorter edge of the paper, and 5 points are marked on the line at equal spacing, leaving 2.5 centimeter from the short edge. From the two edge on the middle point, a mixture of 4 amino acids is applied with the help of a fine capillary. It is dried with the help of hot air blown by a hair dryer. Again, another small quantity of the mixture is spotted at the same place and dried. This process is repeated 2 to 3 times more. On the other point, the solution of individual amino acids of the mixture are similarly applied. The position of these amino acids are marked with a pencil. A schematic diagram of Wattman filter paper sheet for chromatography. A solvent. Okay, the solvent for developing the chromatogram is a mixture of N-butanol, acetic acid, water in the proportion of 12:3:5. This mixture is freshly prepared. The solvent for developing the chromatogram is a mixture of N-butanol, acetic acid, water in the portion of 12:3:5. This mixture is freshly prepared, the total quantity of which depends upon the size of the chromatographic tank. If a paper chromatographic tank is not available, a specimen jar about 20 cm tall and 15 cm diameter with fitting lid can very well serve the purpose. In such a jar, put about 100 to 150 ml of solvent mixture and replace the lid. Ensure that the lid is airtight. If in doubt, apply Vaseline to the lid to ensure that there is no air leakage. In about an hour, the inside atmosphere will be saturated with the solvent vapor. Now fold the paper on which sample has been applied in the shape of cylinder, and the opposing end of the paper is joined with the stapler or thread. Open the lid and place this fold paper in upright position in the jar, the pencil line lowermost and about a centimeter above the solvent. Replace the lid. The paper should stand absolutely vertical. Leave the chromatogram to develop for 10 to 15 hours on or earlier if the solvent has ascending quite near the upper margin of the paper. Take out the paper at the desired time, cut the stitches and hang it to dry completely in the air. After the paper has dried thoroughly, the location reagent 0.2% in hydrogen in acetone is sprayed uniformly on the paper with the help of an all glass sprayer, in the absence of which a pipette can be used. The paper is then allowed to dry first in the air and then in a hot air oven at 105 degrees Celsius for 3 minutes. Purple colored amino acid spots are seen on the chromatogram. Identify the amino acids in the mixture with the help of spots produced by non-amino acids. The RF value of the amino acids can be calculated as distance traveled by particular amino acid upon distance of the solvent from the solvent from the point of origin. Paper chromatography modification. Apart from the above conventional procedure, we can use a modification of the above method which drastically reduces the time required. For this we would require test tube of size 2 cm into 20 cm fitted with a rubber or cork stopper. The stopper should be having a split in the middle. Procedure: cut watermelon filter paper chromatographic grade into strips of 1.5 cm into 15 cm. Make a line with a lead pencil 2.5 cm above one end of the strip. Mark each strip 1 to 3 etc. With the same pencil. Put 2 ml of the chromatographic solvent into each test tube. One tube for amino acid mixture to be tested and one tube each for the individual amino acid. Using a micropipette or a glass capillary, apply 1 to 2 microliter of the amino acid mixture at a point in the center of the marked line on a strip number 2. Similarly, applying the individual amino acids on a strip marker 1 and 3. After the spots have dried, gently put the other end of the paper strip into the slit in the cork so that it holds the paper tightly. Carefully lower the cork carrying the paper strip into the test tube containing the solvent. The lower end of the strip on which the sample has been applied should dip into the solvent. Gently stopper cork the test tube. Ensure that the paper strip hangs freely vertically and does not touch the side of the test tube. See that the label of the solvent in the test tube touches the edge of the strip but is below the pencil line containing the amino acid mixture spot. See that the label of the solvent in the tube touches the edge of the strip but is below the pencil line containing the amino acid mixture spot. Leave the tube undisturbed for 45 minutes to an hour so that the solvent migrates up to the upper end of the strip near the cork or to about 10 cm above the pencil line. Leave the tube undisturbed for 45 minutes to an hour so that the solvent migrates up to the upper end of the strip near the cork or to about 10 cm above the pencil line. Remove the strip carefully and mark the solvent front with pencil. Dry the strips. Leave the tube undisturbed for 45 minutes to an hour so that the solvent migrates up to the upper end of the strip near the cork or to about 10 cm above the pencil line. Remove the strip carefully and mark the solvent front with pencil. Dry the strip in a hot air oven at 100 to 110 degrees Celsius for 10 to 15 minutes. Dip the strip in 0.2% ninhydrin solution or a spray ninhydrin over the paper using a all glass sprayer. Allow it to dry in the air and then it a hot air oven at 205 degrees Celsius for 3 minutes. Purple colored amino acid spots are seen on the chromatogram. Compare the position of the separated amino acid spots in strip 2 with the position of the individual amino acid spots in strip 1 and 3. Calculate the RF values and compare. Thin layer chromatography TLC. Unlike paper chromatography, TLC is a special type of chromatography which is performed on a sheet of glass, plastic, or aluminum foil, which is coated with a thin layer of absorbent material, usually silica gel or aluminum oxide. Thin layer chromatography can be used to monitor the progress of a reaction, identify compounds present in a given substance, or third, determine the purity of a substance. Principle of TLC. Thin layer chromatography uses a thin glass plate coated with either aluminum oxide or silica gel as a solid phase. The mobile phase is a solvent chosen according to the properties of the component in the mixture. The principle of TLC is the distribution of a compound between a solid fixed phase, the thin layer applied to a glass or plastic plate, and a liquid mobile phase, eluting solvent, that is moving over the solid phase. A small amount of a compound or mixture is applied to a starting point just above the bottom of TLC plate. A small amount of a mixture is applied to a starting point just above the bottom of TLC plate. The plate is then developed in a developing chamber that has a shallow pool of solvent just above the level at which the sample was applied. The solvent is drawn up through the particles on the plate through the capillary action, and as the solvent moves over the mixture, each compound will either remain with the solid phase or dissolve in the solvent and move up the plate. Whether the compound moves up the plate or stays behind depends on the physical properties of that individual compound and thus depends on its molecular structure, especially functional groups. The solubility rule, likes dissolve like, is followed. The more similar the physical properties of the compound to the mobile phase, the longer it will stay in the mobile phase. The mobile phase will carry the most soluble compounds the farthest up the TLC plate. The compounds that are less soluble in the mobile phase and have a higher affinity to particles, the TLC plate will stay behind. Materials required. Plates are usually made of glass, 3 to 2.5 cm thick. Size of the plate are 20 cm square, 10 cm square, 10 into 20 cm. Absorbent, silica gel, aluminum, cellulose. Mobile phase, usually it is organic solvent or mixture of organic solvent. Procedure. Preparation of chromatography chamber. Pour the solvent in the chromatography chamber at least 30 minutes before the procedure and choose the lid of chamber. If any doubt, secure it with Vaseline. Formation of slurry. Silica gel 1/2 volume by weight 8 gram in 16 ml of water, or cellulose Mn 1/4 volume by weight 3 gram in 15 ml of water is required for 20 into 20 cm plate. Gypsum is added in slurry as an inert binding reagent. Preparation of plates. In a stoppered flask, slurry is made as per instruction and shaken vigorously by hand for 1.5 minutes to produce a suspension. Preparation of plates. In a stoppered flask, slurry is made as per instruction and shaken vigorously by hand for 1.5 minutes to produce a suspension. Using a spreader, slurry is spread over glass plate immediately. Thickness of absorbent layer on glass plate should be 200 to 250 nanometer. Spreading should be completed within 4 minutes. Otherwise, Plaster of Paris will hydrate and spreading will be impossible. Dry the plate on labeled surface for 30 minutes at room temperature. Note cellulose produce thin layer of good mechanical strength without binder. Activation of the plate. Plate is activated by heating in oven at 110 degrees Celsius for 1 hour. The bottom line. Spotting the plate. Using a pencil, draw a line across the plate 2 cm mark above the bottom line. This is the line on which we spot the plate. Take care not to press so hard with pencil so that absorbent layer will be disturbed. A capillary tube is taken with internal diameter of 0.4 mm for spotting the plate. 0.5 to 50 microliter sample volume can be applied. Dip the capillary into the solution and gently touch the end of the mark. Dry it with a dryer and repeat it with 2 or 3 times. Don't allow the spot to become too large. There are certain precautions to be taken during sample application. First, sample should be dissolved in a non-polar solvent, as polar solvent has a tendency to spread out. Or B, sample spot should not be more than 2 to 5 mm. Solvent should be volatile liquid. Development of plate. The plate should be held vertical in the chromatographic chamber. Solvent should be filled up to 0.5 cm in the chromatographic chamber and point of origin should be above the solvent. Continue the run until solvent font reaches up to 1 to 2 cm from the top of the plate. Usually it takes 1.5 to 3 hours to run. Visualization of a spot. If component of sample are colored, it is observed directly. Observation under UV chamber. Preformed TLC plate containing fluorescent indicator which makes TLC plate glow green under UV light of wavelength 254 nanometer. A spot will be seen as quenching the green light in UV chamber, yielding a dark purple spot. Iodine chamber. Organic spots on the plate turn blown and can be easily identified. Spraying with a reagent that will react with one or more component of sample, example ninhydrin for amino acid mixture. Troubleshooting. Over large spot, diameter of initial sample should be 1 to 2 mm only. Uneven solvent font. Bottom of TLC chromatographic chamber should be flat bottom. In uneven bottom jar, solvent font will be uneven, leading to wrong RF calculation. Slide should not be excessively tilted in the chamber. Streaking. It is seen when too much sample is applied. If more sample is applied, it can move with solution as much as it can, but a substantial amount will be left behind, which forms a streak. Many random spots are seen on the plate. Accidental drop of organic compound can cause many random spots on the plate. Avoid too much handling of plate. Blur. Blue spot on the plate when an ink pen is used instead of pencil. विजुअलाइजेशन ऑफ TLC. ओके फ्रेंड्स, तो ये चैप्टर कंप्लीट हो चुका है. नेक्स्ट चैप्टर है 33 सेरिब्रो स्पाइनल फ्लूइड एनालिसिस. इसे हम लोग नेक्स्ट वीडियो में कवर करेंगे। थैंक यू, बाय बाय। पढ़ते रहिए और मुस्कुराते रहिए। थैंक यू।